So like, this is, what is this, 5, 2, and 5, 4. Factoring. Trinomials. And binomials. So factoring is the opposite of multiplying, so it's like unmultiplying basically. So often we can notice some patterns if we multiply that we can then use to like reverse the process. So if we think about when we multiplied something like 2x plus 3 times x plus 4, for instance. So when we distribute, we get 2x squared plus 8x plus 3x plus 12. So notice that when you actually multiply two binomials like this, like you get 4 terms. When we see the result as a final answer, it of course only has 3 terms because we combine like terms. But at some point in the process, there were 4 terms. So our goal, if we're given this problem to factor, so we want to, I mean, we know what the answer is because we just multiplied, but we're going to pretend we don't. I didn't write factor. Two x squared plus 11x plus 12.
You heard about was there a shooting or something yesterday in Belgrade schools?
It was a threat. They were in.
Lockdown, didn't they?
No, just
Belgrade?
just Belgrade. They were in like shelter in place for a few hours. Yeah, it was like a video thread or something. So if I want to factor this, remembering that it came from something with 4 terms at some point, our goal is going to be to rewrite it with 4 terms by breaking up this middle term, because we see that 11x came from combining 2 terms, 2 middle terms. You guys see what I mean?
You wouldn't know that though, would you?
Well, we know that somehow that happened. Right. We just don't know what they are. Oh. So theoretically, we could be like, hey,
5 and 6,
yeah, how about 5 and 6? So like, let's say 2x squared plus 5x plus 6x plus 12. Right? That's one way we could break up that 11x. And now that we have 4 terms, we can factor this by grouping. So we split it, then I can factor an x out. I get 2x plus 5. Addition between my groups, I can factor a 6 out, and I get x plus 2. Well, that kind of stinks because that doesn't factor, right? That doesn't work. And so we're like, that didn't work. So let's try something else. I don't know, 11x could be written as maybe like 12x minus x, yeah? So like 2x squared plus 12x minus 1x plus 12. So again, just splitting that 11x up into 2 terms. So I can factor a 2x out here, I get x plus 6. And factor a negative 1 out here, I get x minus 12. And that didn't work either because I don't have a common binomial factor. So I could go on like this forever, really. I mean, there's an infinite number of ways to rewrite 11x as the sum of 2 terms, right? It's like, because we can use negatives, right? So like I can make it as big as I want as long as I subtract something that's 11 less than it. So it's not very productive to just like guess how to break up that 11x. So we have something called, it's called the AC method. For rewriting ax squared plus bx plus c with 4 terms.
So it always has to be the variable then?
What do you mean?
Well, you couldn't do like the 12, right?
Right, okay, great question. So this is one of the reasons that we write it in descending order first, so that that middle term is the one that we're always breaking up. And the reason that it has to be that one is because when we multiply two binomials like we did up top, the two terms that we combine are always those two middle terms, the x terms. We never get 2x squared terms or 2 constant terms. It's always 2x terms. And that comes from like this guy and this guy when we multiply. So there's always going to be 2 terms that contain just an x. So the way that we're going to do this is we are going to find 2 numbers with, come on, stop it, a product of AC. So these 2 numbers that I find, when I multiply them, product means multiplication. When I multiply the 2 numbers, I have to get the same thing that I get when I multiply the coefficient of x squared and the constant term. So in this case, AC would be 24. 2 times 12. So this is my A, this is my C. So the 2 numbers I'm looking for, when I multiply them, I have to get the same thing that I get when I multiply that first number and the last number. And so that's one restriction they have to satisfy. And the second one is that, well, we already said we're breaking up that middle term, right? Which means the 2 numbers that I choose have to add up to the middle term. So, and a sum of B. So sum means addition. So when I add them, I have to get 11. This is wicked fun because it's like a puzzle. So the best way to go about it, in my opinion, is to work systematically. So we already talked about how there's an infinite number of pairs that add to 11, but there is not an infinite number of pairs that multiply to 24. There's a finite number of pairs of factors for the number 24. So my AC is 24. My B is 11. Does everybody see where I got those? So A is the coefficient of x squared, B is the coefficient of x, and then C is the constant term. So AC is 2 times 12, which gives me 24. And then B is 11, so the coefficient of x. So that's just the standard form of a trinomial is we have 3 terms, and so we label the coefficients A, B, and C. So first times last gives me my AC. That's got to be my product. And then the middle term has to be my sum. So the next thing we're going to do is list pairs of numbers that multiply to 24. So remember the very first problem that we ever did in this class where you listed all the factors of, like, I think it was 72, right? And you did sort of the bookend thing where you're like 1 and 72, 2 and 36. We're going to do sort of that same process to write down all the pairs of factors of 24. So 1 times 24 is 24. 2 times 12. 3 times 8. 4 times 6. The next number I would try is 5, but 5 doesn't go into 24. The next number I would try is 6, but 6 is already on my list, and so that's how I know I'm done. So I strongly recommend that you don't just like be like, oh, what are some factors of 24? Like, go in order, because if you miss one, it's going to be the one that works. Like, just every single time. The one that you forget is the one that you needed. So start at 1 and then be like, does 2 go into this number? Does 3 go into this number? Does 4 go into this number? And keep going until you repeat yourself. So until you get to a number that's on the right side of your list. So we have pairs of numbers that multiply to 24. Now we want to know which of those pairs also adds to 11. So 1 plus 24 is 20. 2 plus 12 is 14. That does not add to 11. 3 plus 8 is 11. And notice we already kind of knew that those were the ones that we needed, but we won't always have that, right? If we had that, we wouldn't need to do this at all because we know how it factors. So now we're going to rewrite as ax squared, so the first term does not change, and then something x plus c, the last term does not change. These two coefficients are the numbers found in step 1. I know this seems like a lot of work. Once you do it a few times, it gets a lot quicker. You just kind of have to get like the process down, but it gets pretty efficient after you practice a little bit.
And the only reason you put the addition in there is because that's what it is on the thing. So if it's a negative, you just transfer negatives, right?
Right. If it's negative, then you're adding a negative, so we write that as subtraction. Yep.
I just want to make sure it wasn't always supposed to be positive.
No, yeah, and we'll talk a lot about signs here in a minute when we get one that doesn't have all positives. I just wanted to start with the simplest case. So now we're going to rewrite this as, let's see, get rid of that, 2x squared plus 3x plus 8x plus 12. The order that you write those numbers in doesn't matter. If I wrote 8x plus 3x, I would end up with exactly the same thing. So like the preliminary steps would look different, but I would end up with the same factors in the end. So now we're going to factor by grouping. So I can factor an x out. Addition between my two groups, and then I can factor a 4 out. In this step, if you don't get that common binomial factor, so we have, notice now we have a common factor of 2x plus 3. If you don't get that in this step, then you made a mistake choosing your numbers. Like this always works if you choose the numbers correctly. So if you find two numbers that truly satisfy those two requirements, this will always factor. So there's a few places where you can check to see if you've made mistakes. This is one of them. Like if you don't get common factors in the parentheses, then you should go back and check, especially check your signs. Signs are usually where we make mistakes with these. But if those two numbers are correct, this will factor by grouping. So now we have a common factor of 2x plus 3, and then times x plus 4, which is, lo and behold, exactly what we started with up here when we did the multiplication, right? Another benefit of this process is that if you can't find, so I listed these 4 pairs of numbers. If I had added all of those and none of them added to 11, that would tell me that this polynomial was prime, so that it didn't factor at all. So you don't have to go through the process of like guessing and checking all these different possibilities. Like if you can't find those two numbers, then the polynomial simply doesn't factor. Any questions about the process in general? We'll do several more examples here. But so far, so good?
Yes.
Okay, let's do more. Let's do 20 minus 9x plus x squared. So remember from yesterday when we started our factoring strategy, what was the first thing we always did?
Put them in descending order.
Yeah, we put it in descending order. If you don't put it in descending order, then it's really easy to get your A's and your C's all mixed up, right? So we want it in descending order so that everything works out exactly like we said it would when we wrote down what the AC method is. So we're going to write this as x squared minus 9x plus 20. So A is 1 and C is 20, which means A times C is 20. And then B is negative 9. So now let's talk signs. If you multiply two numbers together and you get a positive, what can you tell me about the two numbers?
They have to both be negative.
They either have to both be negative or they both have to be positive, right? So if your AC is positive, your numbers have to have the same sign. If two numbers have the same sign and they add to a negative, what does that sign have to be?
Positive or a negative, right?
Well, so we said that they have the same sign, so either I have two positives or I have two negatives. If I add two positives, what do I get?
Positive.
So if I add two negatives, what do I get?
Oh,
Negative,
half,
yeah.
negative.
So which possibility does it have to be? Do I have two positives or two negatives?
Well, you have a negative. Oh, for A and C, they're both positive.
So for the two numbers I'm about to find.
Well, because you multiplied, so it would
They
be
have to
positive.
be
right?
positive.
So they're going to both have to be negative because they have to multiply to make a positive and they have to add to make a negative.
Right.
So the first thing I always do is decide what the sign of my numbers is going to be, because it is very easy to try to force things to work that don't work if you haven't decided right off the bat what your signs are going to be. So I've decided that they're both going to be negative. The way I decided that is that I looked at AC. Because it was positive, I knew that they had to have the same sign. But because they add to a negative, that means they both have to be negative. Because if you add two positives, you get a positive. We can make a little chart if we wanted to. I don't know if these types of things are helpful, but
Yeah.
so if
Take that code.
AC is positive, AC is negative, B is positive. I don't really like writing B plus. So positive B, negative B. So if AC is positive, then both numbers have to have the same sign. If they add to a positive, they are both positive. If they add to a negative, they are both negative. This is my product. This is my sum. So a positive times a positive is positive. A positive plus a positive is also positive. And then a negative times a negative is positive. And a negative plus a negative is negative. And then if AC is negative, then they have to have opposite signs. If they add to a positive, the bigger number is positive because it has to outweigh the smaller number, right? Like if you have like a 7 and a 5, and you want you want one to be negative and you want them to add to a positive, the 5 has to be negative so that the positive outweighs it. And then if they add to a negative, then the bigger number has to be negative so that the negative outweighs the positive when you add them. So the first thing I always ask myself is, do I have two numbers with the same sign or one of each? And I can figure that out just by looking at this sign. So the sign of AC. And then B tells me if they're both the same. B tells me if it's positive or negative. If I have one of each, B tells me which one's bigger. So for this problem, I have two negatives because they multiply to a positive and add to a negative. So I'm going to write down all the numbers that multiply to 20 and make them all negative. So 1 and 20, 2 and 10, 3 doesn't go into 20, 4 goes into 25 times. And then the next number I would try is 5, which is already on my list. So which one of those pairs adds to negative 9? So those are my two numbers. And so we'll rewrite. Our first term stays the same. Our second term we split up into negative 4x minus 5x. And our last term stays the same. Now that we have four terms, we're going to factor by grouping. So I'm going to factor out an x. There's subtraction between my two terms. Common factor of 5, that means I'm really factoring out a negative 5, right? So x minus 4. And we get x minus 4 times x minus 5. Look good? Okay, let's do like a million more. This type of factoring, so factoring trinomials is the type of factoring you will do most often. They just come up most often in other problems that we'll do, both here and in calculus. Everybody got this? Okay. So let's do... Oh, it won't do that yet. Oh, it won't do that yet. Let's do...
Can we do one that starts with a negative so we have to switch?
Oh, sure.
I don't think
Let's do that.
on the homework.
Sure. So negative 6x squared plus 20x plus 16. So remember that the first thing we do is put it in descending order. That's taken care of. The second thing we do is we factor out a GCF and we factor out a negative if that first term is negative. So my GCF is going to be 2. And then I notice that that first term has a negative coefficient. So instead of just taking a 2 out, I'm going to take a negative 2 out.
Bless you.
So I've got negative 2 times 3x squared minus 20x. No. Minus 10x, sorry, I'm just copying at this point, minus 8. And so now that negative 2 is going to come along for the ride in every step because you don't want to lose it along the way. But in reality, all we're doing now is factoring this polynomial. Like the negative 2 doesn't play into anything that we're doing from this point on. It just comes with us. So when I look at my AC, My A is 3 and C is -8. And so I'm going to get -24. And then B is -10. So if my product is -24, am I going to have two numbers with the same sign or two numbers with opposite signs? Opposite signs. And you don't even have to worry about which one's bigger at this point. You can figure that out after you've made your list if you want. In order to make the list, like, you really need to know if you're doing opposite signs or the same sign. So let's see, we've got 1 and 24, 2 and 12, 3 and 8, 4 and 6. And then since B is negative, do we want the bigger number to be negative or the bigger number to be positive?
You want the bigger number to be negative?
Right, because we want the negative to outweigh the positive. So I'm just going to go through and do this. And so which pair of numbers is it?
The 2 and 12?
Yes. Notice how easy it would be to make a mistake if you didn't decide on your signs first, because 4 plus 6 is 10, right? If you had done two negatives or two positives, then it would have been 4 and 6, not 2 and 12. So like this is why this deciding on your signs is so important, like at the beginning, so you don't try to force it. Be like, oh, it's 4 and 6, and like I just have to make them both negative.
Because you'd have a -2 with 4 and 6, right?
Exactly. But if you did -4 and -6, those would add to -10. However, they wouldn't multiply to -24. They'd multiply to +24. It can be tempting if you don't decide ahead of time to like change signs to make B work and then mess up AC like without meaning to. So now we're going to rewrite. I've got my -2 that's coming with me. Then I'm going to use brackets just so they look different than my parentheses. And we've got 3x squared plus 2x minus 12x minus 8. So my first group, I can factor out an x. I get 3x plus 2. There's subtraction between my groups, and then 12 and 8 have a common factor of 4. So I'm really factoring out a -4, which leaves me with 3x plus 2. And so our final answer is -2 times 3x plus 2 times x minus 4. See, this is fun, right? It's like a puzzle, huh?
I like it because it's the first thing that's made sense in this class to me.
Oh, good.
The only thing.
So we're going to do one with big numbers because you do sometimes see these with large numbers, and it can be somewhat frustrating to try to make that list when the numbers are really big. So I want to show you like a trick to it that makes it a little bit quicker, so you don't have to do like a ton of long division. So let's factor. Oh, we'll just do this one. X squared. Well, no, let's do this. Let's go 2x squared plus 17x minus 55. So A times C is going to be negative 110. Right, so 2 times negative 55. And then B is going to be positive 17. So if I multiply two numbers together to get a negative, are those two numbers, do those two numbers have the same sign or opposite signs?
Opposites.
opposite signs. So I'm going to have one positive and one negative.
That's right. Oh, the light bulb just went on.
Oh, good. I love that moment. So now I have to write a list of numbers that multiply to 110, which is somewhat tedious if you have to do long division the whole time. But if we do the prime factorization of 110, so 110 is just 11 times 10, right? So it's, where should I put this? I'll put it up here. So 110 equals 11 times 2 times 5. Now I can use my prime factorization to like build my list of factors so that I don't have to do any long division. So you might have to do a little long division to get your prime factorization, depending on what the numbers are. But once we get there, you always start with 1 and 110, or whatever the number is. And then if you look at the prime factorization, is 2 going to be a factor of 110?
Yes.
It is. And if I take away the 2 and multiply what's left, I get 55, which is the other factor. So like you don't have to do any division. Is 3 a factor of 110? It's not, because 3 doesn't show up in that factorization. How about 4? If 4 was a factor, I would have to have 2 factors of 2 in my prime factorization, and I don't. What about 5? So 5 is a factor, and if I take the 5 out, I'm left with 22. What about 6? So if 6 was a factor, I would have to have a 2 and a 3 in my prime factorization. What about 7? 8? 9? What about 10?
Yes.
10 is a factor, right? Because I have a 2 and a 5. So 2 and 5 make 10. If I take the factor of 2 and the factor of 5 away, I'm left with 11, and so that's my other factor. And now the next number is 11, and I'm done. So like you can build this list from the prime factorization so that you don't have to do like long division to figure out that like 6 is not a factor of 110, for example. We can see that there's not a 2 and a 3, and so we know that 6 isn't a factor. So now I want the positive number to be bigger because these add to a positive. So I'm going to throw a negative on each of those, and this guy works. So we've got 2x squared minus 5x plus 22x minus 55. So I can factor out an x. Then there is addition between my two terms. And I can factor out an 11. And we get 2x minus 5 times x plus 11. You know what the coolest thing about factoring is? Is that if you want to make sure that you did it right, you can just multiply and make sure that you get what you started with. Like on a test, it's always nice to know if you did it right before you turn the test in, right? So if I took 2x minus 5 and x plus 11 and I multiplied them and combined like terms, and I got 2x squared plus 17x minus 55, then I know I did it right. So you can always check these to make sure that, because when we factor, we're just unmultiplying. And so if you take your result and you distribute, and then combine like terms, that's what I started with, right? If I didn't get that, like if I got something else, then I'd be like, oh no, I made a mistake. And when you do make mistakes, often they're very subtle. Like you'll end up with like a negative 17 instead of a positive 17 or like something like that. So often it's just little things like signs that you want to check for. So that's one of the reasons that you want to be so careful not to like force things to be what you think they should be, but actually like see what they really are. Like when you do the addition and the multiplication, like you don't want to be like, oh, I know this should be 2x minus 5, not 2x plus 5, so I'm just going to put a minus there, right? Like if you like make sure it actually belongs there, then that's how you catch yourself when you make errors. Okay. Let's do a couple more of these, and then I'll give you a couple to try before we talk about binomials, which I promise aren't that much worse than this at all. It's basically the same thing. Let's do, ooh, this one looks fun. Oh no. Yeah, sure, let's do that one. What should I do first? Descending order, very good. And then I've got my AC is negative 48. So 24 times negative 2. And then B is negative 47. So am I going to have two of the same sign or one of each?
One of each.
One of each, good. And let's see, we got 1 and 48, 2 and 24, 3 and 16, 4 and 12, 5, 6, and 8. And then the bigger number is going to be negative because it adds, or they add to a negative. So my negative has to outweigh my positive, and it turns out that it's just the first one. And if you saw that before you kept making your list, that's fine. Just make sure that you've decided on your signs before you start writing those pairs down, because just like we saw in that last example, like it's really easy to see two numbers and be like, oh, those add to 10 or whatever, without thinking about the signs and how that affects their sum. So we have 24x squared minus 1x plus 1x minus 48x minus 2. So I'll factor an x out. Subtraction between my two groups, 48 and 2 have a common factor of 2. So we're really factoring out a negative 2, which gives me 2 positives. And so we have 24x plus 1 times x minus 2. Okay, here's one for you guys to try. We'll do 3x squared minus 5x minus 2. Okay, so AC is negative 6 and B is negative 5. So this is another place where we see how important it is to decide on our signs, right? Because you've got 1 and 6 and you've got 2 and 3. Well, if they have the same sign, 2 and 3 would add to 5. But if they have opposite signs, then 1 and 6 add to 5, right? So because they multiply to a negative, I need one of each. That's not the right direction. I need one of each. And so because they add to a negative, I know the bigger one is going to be negative so that it outweighs the positive. And so these are my two numbers. Because if I did 2 and negative 3, that would add to negative 1 instead. So 3x squared plus 1x minus 6x minus 2. Factor out an x. Between my terms, I have a negative, common factor of 2, so we're really factoring out a negative 2. So we get 3x plus 1. And then times x minus 2. It's so cool, right?
Cool when you finally get it.
So the trick to all of this is to just take it, like do it nice and systematically and not try to rush it. Like you will get faster at this, but if you try to rush to getting faster, you're just gonna get fast and wrong. So if you will eventually get faster at it, but you want to make sure that you're thinking through all the little pieces as you start, so that when you get really fast at it, you're doing it correctly still. Do you guys want a little break before we start something completely new? I don't know. We don't usually take a break, but I don't want to like overwhelm you either.
Take 5.
You want to take 5? Okay. Let's factor 3x squared plus 4. So remember when we were doing division and we talked about missing terms? So how like if we have a degree 2 term and then a degree 0 term, that we're like missing a degree 1 term, right? If we think of this as like a trinomial, we're missing that bx. You guys see it? So in order to write this with 3 terms, all we have to do is put 0x in as our middle term. And then all of a sudden we can factor this as a trinomial. So my AC is 12 and my B is 0. So if I have two numbers that multiply to a positive, you agree that they're either both going to be positive or they're both going to be negative?
Yes.
What do you know about two numbers that add to 0?
One has to be positive and one has to be negative.
Yeah, the only way you can add two numbers to get 0 is if one's positive and one's negative, right? Like 2 positives will always get a positive and 2 negatives will always get a negative. And so this is prime. Done. Because we need a positive and a negative to add to 0. So the upshot of that, so the cool thing about binomials is only a very specific type of binomial factors. The first thing we just learned is that in order for a binomial to factor,
It's supposed to be both to add to 0. I'm assuming.
but to add to 0, isn't that what it says?
Oh, yeah.
Okay.
Didn't make sense when I read it the first time.
To factor, AC must be negative. And since we always rewrite these with a positive leading coefficient, what that really means is that you have to have subtraction between the two terms, right? Like, this has to be negative. And that's just because we know that if it's a binomial, that middle term is going to have a coefficient of 0. And in order for two numbers to add to 0, one has to be negative and one has to be positive. But if you multiply a positive and a negative, you get a negative, which means AC would have to be negative if this was going to work. So, and like these generalizations I'm talking about, like, if you don't remember them, that's fine. You just try to factor it, and you'll notice that there aren't two numbers that multiply to 12 and add to 0. So it's not like if you forget all this stuff that we're talking about, like you can't do it. But there are some shortcuts. If you can start to notice some patterns, then it goes a little bit faster. So let's try one that does have subtraction. I mean, heck, what if we just said factor 3x squared minus 4 instead? Like, that takes care of the problem, right? I needed a negative for my AC, so we're going to rewrite this as 3x squared plus 0x minus 4. And so now AC is negative 12, which means that I'm going to have, I keep doing that, a positive and a negative, which we said is what we need in order for this to factor. And then B is 0. So let's make our list. So 1 and 12, 2 and 6, 3 and 4, we'll make one of them negative. Do any of those add to 0? So in addition to one of the numbers being negative and one of the numbers being positive, like there's more of a restriction here to add to 0, right? What else, or what other property does the two numbers have to satisfy if they're going to add to 0? Yeah, they have to be the same. Like, the numbers don't just have to have opposite signs. Like, they have to actually be opposites of each other. Like, they have to have the same magnitude, right? Like, if one of the numbers outweighs the other one, we're always going to get a positive or a negative. The only way to get 0 is for them to have the same magnitude but opposite signs. So, like 3 and negative 3, 4 and negative 4, which means in order to factor AC must be negative and a perfect square. So when we say perfect square, we mean that it's a number times itself. So like 1 is a perfect square because 1 is 1 times 1. 4 is a perfect square because 4 is 2 times 2. 9 is a perfect square. 3 times 3. 16 is 4 times 4. 25 is 5 times 5. Those are the numbers that we refer to as perfect squares. And if AC is a perfect square, it turns out that both A and C also have to be perfect squares. There's no way to multiply two numbers together to be perfect squares without them both being perfect squares unless they have a common factor, which we would have taken out when we took out the GCF if that was the case. So what this really means is that to factor a binomial it must be what we call the difference of squares, which just means it's a perfect square minus a perfect square. So like 4x squared minus 9 is the difference of squares because 4x squared is a perfect square and 9 is a perfect square, and subtraction between them makes it a difference. So again, you don't have, if you don't remember this, it's okay. You put your 0x in and you try to factor, and if it doesn't factor, you'll find out that it doesn't factor. But if you can remember the form that it has to be in order for it to factor, then you can say it's prime a lot quicker without actually having to go through all of the calculations. So let's...
Was that second one prime as well?
Oh, yes. Sorry. Let me write that. Prime. Because none of our pairs added to 0. So let's do one that does factor. So this is a binomial. The first term is a perfect square because 25 is 5 times 5, x squared is x times x. The last term is also a perfect square because 1 is 1 times 1. And it's a difference because there's subtraction between the terms.
Also, the variable has to be a square of a square too?
Yeah, we're going to talk more about higher order polynomials tomorrow, but like if that was x to the third, it wouldn't factor.
Prime,
Yeah. But we'll talk more about like when we have higher order ones tomorrow and how that works. So I'm going to rewrite this with that 0. So my AC is negative 25, which is negative and it's a perfect square, so that's hopeful. And then my B is 0. And if the numbers are going to add to 0, then we know they have to be the same number, right? So I don't need to bother making a big list. I know that 5 and negative 5 are the only possible numbers that will work. And I'm going to double check that 5 times negative 5 is in fact negative 25, so I get my AC. I didn't mess up any signs. And so we have 25x squared plus 5x minus 5x minus 1. So I'll factor out a 5x. Subtraction between my terms. There is no common factor for 5 and 1 other than 1. So I'm factoring out a negative 1. And we get that 5x plus 1. So we get 5x plus 1 times 5x minus 1. Now here's another pattern that we can notice, and I strongly encourage you guys to do this the long way a few times until you really start to notice the pattern, because like when it comes to factoring, there are a lot of patterns that lead to really nice shortcuts. The way I see things like that is kind of like, you know those paintings that are like made of dots and there's supposed to be like a sailboat in them or whatever? And like you can stand there with your friend and they can be like, see the sailboat, see the sailboat, see the sailboat. And until you actually like see the sailboat, like you don't see it, right? No matter how many times people tell you it's there. Like it's the same way with shortcuts in math. Until you see the pattern that produces the shortcut, like somebody can tell you the shortcut over and over and over again, but until you see how it works and why it works, like you're not going to use it correctly. Like you're not going to see it right. So there is a shortcut here, which is that notice these are the same other than the sign between them, and that the coefficient of the first term is just the square root of 25, and the last term is just the square root of 1, right? Like, that first term we get from just taking the square root of the first term, and the second term we get by taking the square root of the second term, and then we just flop the signs. So that will always work. It's what the difference of squares, they factor into what we call conjugates, which are binomials that are exactly the same except for the operation between them is opposite. And conjugates come up in a lot of different places in math. We'll see them a few other times in this class and then in other classes as well. So, but that shortcut, again, if you aren't exactly sure when it works and why it works, then it's really easy to make mistakes with it. It's really easy to try to factor something that doesn't actually factor using a shortcut. And so definitely do this the long way a few times so that you can see it and you can see when you can actually factor and when you can't. Because I do encourage you to use the shortcut eventually, but not until like it really makes sense and you can see that pattern. So let's do a couple more of these. Let's factor. So here's a nifty trick. So I noticed that there is subtraction and that both terms are perfect squares, which gives me hope. So I'm going to put my 0 in. And my AC is equal to negative 49 times 25, and I have like no idea what that is equal to. And frankly, I don't really care. And the reason I don't really care is that I'm going to use prime factorization to get my pair. So I know that 49 is 7 times 7, and I know that 25 is 5 times 5. So if I want two numbers that are the same, that give me 2 factors of 7 and 2 factors of 5, what do those two numbers have to be?
Wait, what'd you say?
Say that again.
So I want two numbers. I want to take those.
35.
Yes. I'm going to take the 2 7s and the 2 5s and split them apart in such a way that I get the same factor in each pair. So I'm going to take 1 factor of 7 and 1 factor of 5. So I get 35 and negative 35. Sorry, I don't think I put that into words very well. But you guys see it? So when you have really big numbers like this, if you know that middle term adds to 0, just do your prime factorization and like take 1 factor for each of your numbers. Like, so split it in half, basically. So now we have 25x squared plus 35x minus 35x minus 49. And in this first group, I can factor out a 5x. And I get 5x plus 7. Subtraction between my groups. 35 and 49 have a common factor of 7, so I'm really factoring out a negative 7, which gives me 5x plus 7. So 5x plus 7 times 5x minus 7, which again, notice that that first term is the square root of 25, and the second term is the square root of 49, and we just use opposite signs. Yes?
Shortcut, and you have to.
No, you can totally use it. Just be careful that you're using it correctly and that you know when you can't use it, which is the most important part, is when you see something like this. Let's see, 36x squared plus 25
there's the plus sign there.
Oh, yeah.
It's prime, right? So this doesn't factor because there's a plus sign there. If we did 6x plus 5 times 6x minus 5, that would give us a negative 25. So that's why we have to be so careful is when you do it the long way, you notice when it's prime. If you use the shortcut, you have to know exactly when it factors and when it doesn't so that you can say it's prime.
You could kind of just take the initial problem, just do 6 times 6 above the 36. If it was negative, then do
Yeah.
negative and do 5,
Oh, yeah.
5, and then you know it's 6x plus
Yeah, you could be like,
5.
if this was 36x squared minus 25, you could be like, oh, this is 6 and 6, and this is negative 5 and 5. And you get 6x plus 5, 6x minus 5. Again, you just have to make sure that you know when you can do it and when you can't. But I mean, I'm hoping that all of you will eventually use the shortcut because it sure is a whole lot quicker than doing the work every time. It's just a matter of being sure when you can and can't do it. Okay. I think that probably the most useful or the best use of our time at this point is for you guys to work on your homework so that you can practice a bunch of these. Because now that we know how to do them, it's just a matter of like practicing them a bunch so that we can like get used to like getting our signs right and things like that. So